All right, guys, I've had a few emails on this graph, which is in your Nearpod for atmosphere, the layers of the atmosphere that you're working on today, which is Monday, April 20th. And I want to clarify a few things and maybe help you understand what this graph is saying. So when you look at a graph, the first thing I do is try to figure out what is the information that it's telling us. So on this graph, I see kilometers, I see miles. If I didn't know what those abbreviations stood for, I'd probably look them up, go to Google. What does KM stand for? It would tell you kilometers. What does MI stand for? It stands for miles. Well, they're both a measurement of distance, so you can use either one. I prefer to use kilometers because in science we want to use metric. So if you see here, there's 10, 20, 30, 40, all the way up to 130 kilometers. Down here is 0. Okay? There's no title on this graph, but if I were to put a title on this graph, maybe I would say distance above 0, which 0 is, in this case, it doesn't tell you, but 0 is representing sea level. So distance above sea level, 10 kilometers, 20 kilometers, 0 miles, 6 miles, 12 miles. As you move up, you're going through the atmosphere. Well, this axis is showing us temperature. So this graph is showing us distance above sea level and the temperature. So temperature with compared to distance, right? And with any graph, you have two axes or two axes. You have a y-axis and an x-axis. So I like to think about things in terms of math. So if we are going to put a y-axis on this graph, that would be the vertical axis. You want to figure out where that 0 spot is. So in this case, I put a line right here. This is 0. So if you were to think about this as a graph like you would in math, here is the y-axis. And then if I had x-axis, it wouldn't be anywhere up here. It would also be where there's 0, which is going across here. So you have an x-axis, the horizontal axis here, the y-axis, the vertical axis. And if you know anything about graphs, especially y and x axes and positive and negative numbers, everything above the x-axis is positive. Everything to the right of the y-axis is positive. And if you thought of this in quadrants, there's a quadrant here, one down here, one down here. In this case, all the numbers would be positive. As you move to the right, these temperature numbers are positive and they get larger. As you move up, these distance numbers are positive and they move larger. But if you think of things on this other axis, or on this other quadrant, they're not both positive. It's positive as you move up because it's still above the x-axis, but it's negative as you move to the left. So this is 0, but you're getting smaller or negative numbers, negative 20, negative 40, negative 60. The distance is still positive though, so positive going up, negative going to the left. Okay. Now you have this yellow line, which is going to represent what that temperature is as you move up through the atmosphere. And you can see that temperature goes back and forth between starts in positive, goes over here to negative. And these graphs are hard to read sometimes because it's like, well, it's going up, but what's that number really saying? So let's look at where this graph starts. So at sea level, or 0 feet, 0 kilometers, that's right at the ocean. The temperature is where this yellow line meets this x-axis. So I would say it's not right on 20. 20 is right where this blue line is. 0 is right here. Halfway in between would be about 10. So I'd estimate maybe about 15. So when the temperature at sea level, and this is average, going to be average temperatures, 15 degrees Celsius around sea level. Okay. As you move forward or go up in elevation, elevation is the height above sea level. As you go up, the temperature is at, even though this line's going up, if you look at where the temperature is at, by the time it gets up to here, that's a little bit above 10 kilometers, maybe 12 kilometers, that temperature went down because we're going to the left. So that temperature now is right in here if we're going to draw a line all the way down. I would say that's not -50 would be halfway in between, maybe -55 in there. So if you're looking at the troposphere, right here, we're starting at 15 degrees, but by the time you get up here, it's -55 degrees. So that temperature, think about it, did it decrease or increase? And you can begin to look at that trend to determine what it is you see. Now, for this lesson, it's just asking you to look at the troposphere. However, you can go through and you can look at the stratosphere and see how that temperature changes as you move on through. Okay? Look at these key points where there's these shifts in temperature. So right here at about 20 kilometers above sea level, it changes again. But it's a straight line right here. That straight line, if you carry it all the way down, would still be about -55. So as you move up from about 12 kilometers to 20 kilometers, that temperature doesn't change. Use this information and what this graph is telling you to be able to understand how that temperature is changing. There's a common misconception as you move up in the atmosphere, it just constantly decreases, the temperature decreases. But you can see on here, that's not exactly true. This line, where it's at 0 degrees, all of a sudden when you get closer to 50 kilometers above sea level, it's back to 0 degrees Celsius. So that's pretty interesting what that does. And this is a really good graph because it shows that temperature and how it fluctuates as you move up. Hopefully that helps you answering that question, and have a wonderful day.